Alright, we have finally reached the more advanced topics of this course. Previously, you have learned about the other two essential web technologies, HTML and CSS. While they should have been pretty simple to begin with, remember, you will need much more reading and practice to master them. HTML has advanced a lot since the beginning, and I'm not even talking about CSS, since that is a different beast of its own. Now, you can proudly say that you can create some sort of static website, perhaps a few animations here and there, and it wouldn't be telling a lie. But without learning JavaScript, you are pretty much stuck there. A simple analogy of the web Triforce is this. HTML are the nouns, or the what's of your app, the CSS are the adjectives, or the how do they look, and the JavaScript are the verbs of your app, or what do they do. The world of JavaScript opens up entirely new possibilities for your web applications, and it is an essential tool for the front-end developer. And while HTML and CSS is also code, these languages have a pretty narrow purpose and are generally called domain-specific languages. JavaScript is a fully blown general-purpose language. What that means for you is that after learning JavaScript, you will not only be able to use that language to create rich web applications, which of course is the main use case for the language, but you will also be able to use the same language for other multiple purposes. Some examples are native mobile and desktop app development, server-side development, machine learning, developing for the Internet of Things, and even such low-level concepts as embedded programming, if you're brave enough. Okay, so before we start the actual coding, I want to show you a small example of what JavaScript can do, or rather, what would happen to your favorite sites if you didn't include JavaScript in it. So basically, YouTube's videos and thumbnails don't load. Or for example, Netflix doesn't load anything except for its logo in the upper left-hand corner. So basically, most of the websites you use wouldn't really work without JavaScript. Although there are some benefits of disabling JavaScript, such as the web is really fast without JavaScript, first of all, and second of all, there aren't any ads, so no auto-playing videos or tell us your email address pop-ups. But that's about it. Downside of it all is that the websites don't work at all. Images don't load, and forms can't be submitted, which is basically the whole point. Alright, I think you now understand the importance of JavaScript. I could talk about the history of JavaScript, but I think I will just leave you relative links to read through after the presentation. I want this lecture to be pretty focused on the important parts. And I know that you are excited to start developing fully blown web applications right away, but we will start with standalone JavaScript code. That means without any CSS or HTML. So please be patient. We must first learn how to use JavaScript independently. And the person in this picture you see is Brendan Eich, the creator of JavaScript. Now, how do you actually start writing JavaScript? Well, there are plenty of ways, but if you just want to code along with me, the quickest way would just be to open up any online code editor, and I personally recommend jsfiddle.net, as you can see. Since you don't need to sign up or anything, you can just start coding right away. So I'm just going to quickly introduce JSFiddle to you. So your layout might be a bit different than mine, but basically we have this HTML pane here, the CSS pane, and what's important to us for now is the JavaScript pane. So these panes are adjustable. You can position them however you want. But what we're going to do is basically write JavaScript here and click run. And we'll see the console right here. This is the output for the HTML and CSS, but since we didn't write anything, it's just a blank screen. But what matters to us in this section is basically the console. So right here we can see it prints out hello, and that's basically how it works. And now this is just one of the many ways how you can execute JavaScript. We will explore more options as we go, but for now this will do. If you have your preferred way, feel free to use that as well. We won't be doing anything complex, so any editor or environment will do. The first thing that we are going to learn is the different data types available in JavaScript. We will start with primitives. Now, what are primitives? They're basically a concept shared by all programming languages, although different programming languages have different primitives available to them. A primitive is essentially the simplest data type available to a programming language. Think of it as a building block to construct more advanced data types and structures. It will be easier to understand with concrete examples, but for now, let's introduce you to the primitives of JavaScript. Let's start off with the number. The number is a data type that stores all kinds of numbers. In other languages, the number data type is divided into more specific data types like integer, float, double, and more. But JavaScript basically supports any format of numbers in one data type. For the more experienced people on this course, the number type in JavaScript is the 64-bit floating point number found in other languages. You don't need to remember that, but what that means is that the maximum number which you can store inside a number data type is a number between 2 by the power of 53, positive and negative. Any value beyond these numbers is considered unsafe, and JavaScript will return the closest approximation of the provided value. In addition to representing numbers, the number type has three symbolic values: positive infinity, negative infinity, and not a number, which I will explain later. The string. The string is a data type that stores all kinds of text information. And that's pretty much it on a high level, but we will of course familiarize with the possibilities of this data type later on. Next up is the Boolean. A Boolean is a logical data type that can only have the values true or false. The undefined. Undefined is a primitive value automatically assigned to variables that have just been declared, or to formal arguments for which there are no actual arguments. A null value represents a reference that points, generally intentionally, to a non-existent or invalid object or address. The meaning of a null reference varies among language implementations. In JavaScript, null is marked as one of the primitive values because its behavior is seemingly primitive. Now, what is the difference between null and undefined? Simply speaking, undefined says that a value is undefined, or rather that the data store has no value whatsoever, while null says that a value is none, but it is intentionally defined as none. The difference is small, but we will later see that there are actually some differences. These 5 primitives were the only ones for most of JavaScript's livelihood, and honestly, these are the only ones you will need for most of your work. But there were a few additions with JavaScript ES6 version, which I will also briefly mention. The begin type is a numeric primitive in JavaScript. With bigints, you can safely store and operate on large integers even beyond the safe integer limit for numbers we talked about earlier. Be aware though that bigints cannot be operated interchangeably with numbers, only with each other. And the symbol value dynamically produces an anonymous, unique value. There is more to it, but the topic is pretty advanced and we won't be covering symbols during the whole course, so feel free to read more about them on your own time. The same can be said about bigints. So there are currently 7 JavaScript primitives. We will now dive deeper into each one of them. We will start off with numbers. It is one of the most commonly used primitives in any programming language. We store numbers, we manipulate numbers, we do map with them, something as simple as incrementing a number or decrementing one. For example, if you like something on Facebook, you increment the likes count by 1. Or if you downvote someone on Reddit, the points are decremented by 1. I previously mentioned that other languages split the number type into smaller primitives for different numbers, but JavaScript can store various integers and decimals in one data type. So basically, integers, positive, negative integers. We can also have decimals, of course, negative decimals, and these are all valid numbers in JavaScript. We also have scientific notation in JavaScript. So basically, all of these are numbers. They don't differentiate by type, like float, integer, they're all numbers. So do keep that in mind. Now, we can also do arithmetic operations with numbers using hopefully familiar operators. So let me just delete that. Let's say 2 plus 2, right? So this is one arithmetic expression. Of course, we can use the minus as well. We can use the multiplication, the division, and so on and so on. What operators you might not be familiar with, well, at least in JavaScript context, is, for example, the exponential operator, which is a double asterisk. So basically 2 to the power of 3, right? Which is 8. Now, JavaScript also uses PEMDAS, which is the order we execute arithmetic operations. The rules are the same as you probably learned in school. First we have parentheses, then exponents, multiplication, division, addition, and subtraction. So basically the only thing you have not yet witnessed is the parentheses. You can use them, for example, like this. So right now multiplication won't take precedence because the parentheses will be first. So basically we will have 5 here and 3 here. That's about it. Now, talking about the modulo operator, which some of you might not know, what it does is basically it returns the remainder of a division between two numbers. For example, if I do a modulus operation with 9 and 3, I would get 0, since 9 divided by 3 is 3 with a remainder of 0. But if I would do a modulus operation with, let's say, 5 and 2, I would get 1, since 5 divided by 2 is 2 with a remainder of 1. Well, it is a bit more complicated than that, but I'm trying to explain it in simple terms. Now, what is the modulo operator useful for? For example, we want to create a tool that lets a person know how much money he will have left if he spends all of his money, for example, on some product that costs X amount of money. So let's say a person has 122 money and the product costs 40, let's say. So we do the modulus operator, right? 122 modulus 40, and the result is 2. So basically that means that the person can spend all his available money on the product and still have 2 money left. We can also calculate exactly how many products he can buy by doing a simple division and rounding the result down. Another useful use case for modulo is determining whether a number is odd or even. If a number is even, the modulus from the number and 2 must be equal to 0. For example, 2 is an even number, right? So if we do modulus 2, we will get 0, because 2 is an even number. But if we do something like odd 3, modulus by 2, we get 1. And that basically means that the number is odd. And that's a pretty easy way to check if a number is odd or even. Now, another useful thing to know about numbers is the not a number value. I have briefly mentioned before that not a number is indeed a numeric type, although it does not look like one. Let's say not a number. It's JavaScript's way of representing numbers that are, well, not numbers. It's pretty weird, I know, but let's see an example and perhaps this will be clearer. So for example, dividing 0 with 0 returns not a number. Let's actually check that. Console log. Let's run it. See, it returns not a number. So doing any other operation like adding, subtracting a not a number will also always return not a number. Let's say not a number. Oops. It's actually case sensitive. Yeah, still not a number, as you can see. Alright, so if you're expecting, let's say, from a user a number, but he inputs a string, for example, haha, and you try to do mathematical operations with it, for example, subtracting it like this, it's also going to return not a number. With some exceptions, of course, as we will find out later, but for now, being aware of the not number is enough, and understanding that this is a reserved keyword in JavaScript, and it is of numeric type. Alright, so next up is the string. Also, one of the most widely used data types in any programming language. So, on a high level, a string is just textual information. An important thing to note here is that you probably think that, like numbers, we can just start typing out text and that will be considered as a string. Well, not quite. Strings are defined using quotes. In different languages, it's important which quotes, double or single, you use, but in JavaScript, you can use 3 types of quotes to define a string. A single quote, a double quote, or the backtick, found just below your escape button on the keyboard. Well, at least in my case. And you can use any of these, but according to convention, JavaScript recommends using single ticks for JavaScript strings and double quotes for HTML markup. But feel free to use anything you like, it's just a convention. So basically, this is how you define a string. You can use single quotes. I've inserted a single quote right here. Hello world. I can use double quotes as well, or I can use backticks. It's still a string. All of these three basically mean the same thing, only they're defined using different quotes. Let me just clear the console. Oh, and do be aware that if you use single quotes to open a string, you must use single quotes to close it. Same goes for double quotes and backticks. What I mean by that is, for example, if I do this, right? Let's just delete these. If I do this, this will be invalid because I've opened up the string with a single quote and I close it with a double quote. So basically, how to fix it is basically replace the double quote with a single quote or replace the single quote with the double quote. And now it's valid. There are sometimes situations, for example, if we use single quotes right here, let's say we want to use a single quote again in the word let's. Well, basically this will result in an error because try to understand why first. Well, basically we opened up the string, right? JavaScript doesn't care what we write. I mean, it doesn't read human language, right? So it sees a single quote, it just thinks that the string has ended, right? And it just ignores this. And this, of course, will result in an error because this is invalid JavaScript, right? So to fix this, we have two options. Basically, we can convert the single quote to use double quotes, and now it's all good. Or if we prefer to use single quotes, we can use the backslash operator, right? So what it does, it basically escapes special characters. So in the resulting string, this backslash won't be visible. Let's check that out. Just log this into the console. As you can see, we get the result let's. So that's basically how you escape special characters. Alright, so compared to numbers, the string type is a little more complex, and we will see why in a second. So first of all, let's figure out why a string is called a string. Well, it's because a string is basically a sequence or string of single characters. Each character is indexed and has its own position in the string, starting from 0. What does this mean for us? Well, we have not covered arrays yet, but since a string is a sequence of indexed characters, we can access each individual character of a string using what's called a bracket notation. So how bracket notation works is, let's say we have some string here, A, B, C, D, right? We add a bracket notation here. So basically, what's on the left of the bracket notation is the object we're trying to access, right? And what's inside the brackets is the index we're trying to access. So for example, if, as I mentioned before, strings are indexed from 0, right? So we just type in 0. Actually, yeah, we will need this result, so let's just put it in this console log here. And let's see what happens. We get the letter A, because it's the first character of this sequence, right? So if we do 1, we're gonna get B, of course. If we do, let's say 3, which is the last letter, D. But if we use something like 4, which is not basically in the string, it's out of bounds, it should be somewhere here where the cursor is, we get the already mentioned undefined, because basically it points to nothing. That's why it's called undefined. I guess it should be a bit more clear now as well. Now this will start to get a little freaky, but we can also use some of the arithmetic operations we have used before with strings. Let me show you what I mean. So let's delete this square bracket notation and add another string to this one, I guess, and let's see what happens. We get A, B, C, D, E, F, G, right? So this is what's called string concatenation. We're basically adding two strings together and we get the expected result. But what about this? What do you think is going to happen? Take a moment to think. Alright. So if you said 4, you might be wrong here, because the actual answer is 22. Because if you noticed, these are not numbers, these are strings, and they don't get converted to numbers when we use addition, because JavaScript determines that, oh, you want to use string concatenation? Sure, I'll do that. But if we would use a minus here, then it would convert the numbers and the result will be 0. But why this happens we will cover a bit later. Okay, so next up is the Boolean. Booleans are pretty simple in the sense that they can only have two values, either true or false. So on their own, they're pretty useless to us, but Booleans are also known to be one of the most important building blocks of our programs. They're the key tool on performing logic operations and other more complicated things, and we will use them a lot in the near future. Do keep in mind that JavaScript is case sensitive, so you have to declare them as lowercase true or false. Also, they're not strings, so we don't need to put them in quotes. Yeah, just ignore that error message right here, because basically this is not correct, but I just want to write them out. So we covered the three most important primitives of JavaScript: the number, string, and Boolean. With that knowledge, we will be able to use these basic building blocks to build something greater. But knowing how to simply define these primitives won't be much use to us. We were using what is called literal values. We need to figure out a way to actually store them for later use. And this is, again, a fundamental concept in JavaScript, and you need to make sure that you understand it fully. Introducing variables. Now, what are variables? On simple terms, you can imagine a variable as an empty box where you can put a value inside of for later use. How do we define variables? There are multiple ways we can do that, but let's start with a simple one. Introducing a new JavaScript keyword, let. The structure of using let is pretty simple. So we write out let, then we give a name to our new variable, or more specifically, it's called an identifier. For example, my name, right? Then we continue with an equal sign, as to say what our new my name variable will be equal to, and we assign a value to it. In this case, let's assign a string to the my name variable, which seems logical since names are strings, right? So let's type it out. Alright, let's close it off. Now, to actually use it, we just write out our new variable's name, and the JavaScript console will just return what is stored inside the my name variable, which is our string. So let's try it out. So, console log name, and let's run it. Here we go. We get the name that's stored in the my name variable. If I were to try accessing a non-existent variable, for example, let's say SumVar, and try running this, I will get an error. On caught reference error, SumVar is not defined, which is correct because I have not defined the SumVar variable. I only have my name. So basically, if we run this, it's all good again, right? In simple terms, using a declared variable is like writing it out by hand, like we did before when we were learning about the primitives. What I mean by that is, let's say we have some math operations, right? So now we already know how to write out or hard code the values straight into the console. What I mean by that is, let's say 2 plus 2, right? And we run it, we get 4. But let's try something a bit more complicated. Let's delete this and create a variable called sum. Don't assign anything to it. Then assign 2 plus 2 and console it out. And we can actually reuse it instead of rewriting it every time. So we can say 3 times, right? We get Triforce. Remember the string examples? Let me introduce you to a property that every string has, length. So let's define some string here and access its length property using the dot notation. So let's delete this for now. Oops. Let's see what it does. It returns 5. So basically, the word hello has 5 letters, right? So length basically returns a numeric representation of the string's length. And all strings have access to it, and you have to use the dot notation like this. We will learn about it a bit later. So basically, since you already know that strings are a sequence of chars, and you know about the length property, we can utilize that now to, for example, extract the last character from any string, instead of counting the letters and just specifying the needed index like we did before. Let me show you what I mean. So basically, we can just put this whole word inside some variable, right? So before, if we wanted to access the last letter, we would just count the letters, right? Starting from 0. So H is 0, 1, 2, 3, 4. Okay, so we can just use text now. Since it's in our variable, it's the same hello. We use the 4. And we should get the letter O, right? But what if I don't know what this text is? It's just some variable. I don't really know or care what's inside that variable. So how do we utilize text length and this bracket notation to get the last letter from the string? So take a moment to think about it. All right, so basically the solution is to actually use the same variable, use the length property, because basically this is the same as doing this, right? Like we just did. Instead of using the hard-coded string, we use the text variable. We get the length, but this would throw an error. And why do you think is that? Because, well, length is 5, and as we remember, accessing strings requires you to use the 0-based indexing. So basically the first letter is 0, but when length counts the actual length of the string, it starts counting from 1. So that's a big difference. So we need to subtract 1 from the result. And we're still getting the same O right here. So this is basically just a small trick to utilize the length property, the bracket notation, to get the last letter of a word. So I think that this is pretty useful in some cases, but yeah, just a small trick. Now, before we continue on with other ways to define variables, let's sort some things out first. So first of all, you might be wondering about the weird name I gave the myName variable. So we're talking about myName, right? So instead of calling it myName like this, like a normal person would, I used what's called camel case. So camel case is basically the convention for JavaScript, where instead of using spaces, since they're not allowed in variable names, you capitalize each word that you would use a space for. Like, for example, instead of using a space here, I'm just deleting the space and capitalizing the next name, right? So another example is, instead of like my cool variable, I would delete the spaces and capitalize the letters, right? And this is called camel case. So, well, actually, you're free to call your variables however you want, but there are a few limitations. First of all, JavaScript variable names must start with a letter, an underscore, or a $sign. Subsequent characters can also be digits. Like, you can't start with a digit, but you can use it later on if it's not at the start. Second of all, the names are case sensitive. So hello world does not equal hello world. It has different casing, right? Okay, so let's just move on to the other keywords that let us declare variables. I'll delete everything here. Without let, there's also const and var. All of these three keywords work the same way. You specify the keyword, specify the identifier, assign it a value, and there it is. Same goes for const and let, as we've seen before. But these three keywords do have some different behaviors in how they work, and we will briefly discuss it here. So before JavaScript ES6 version, we only had the var keyword to define variables. And there are issues associated with variables declared with var though, and that is why it was necessary for new ways to declare variables to emerge. So first of all, let's get to understand var before we discuss those issues. So first of all, var variables can be redeclared and updated. What this means is that we can do this, and it will work just fine. Let's see. As you can see, we get the new value here. Also, of course, this works as well. But this is not redeclaring, this is basically changing the value, so it's all right. Now speaking about hoisting, the term hoisting itself is a JavaScript mechanism where variables and function declarations are moved to the top of their scope before code execution. So what this means is that if we do something like this, what do you think is going to happen? I'm going to let you pause the video and think. This is not really normal behavior, but let's see. Oh, for some reason it says result. Yeah, let's just change it to some value. I think it's just global scope, right? Yeah, you see undefined. Result was basically just because this JS Fiddle platform had defined the variable name on some other scope, perhaps global scope. So just ignore that, but let's say we have a custom variable here, which is definitely not duplicated. So we create it, it gets hoisted, and what that means is basically we have this situation. Sorry, I'm not using camel case before. Let's change that. So basically what this does is converts it to something like this. So at this point in time, custom variable is undefined since it doesn't have any value. It gets console logged out, and only then it gets its value assigned to string. And that is what hoisting is. So var doesn't throw errors, and we will see that other things do throw errors, like let and const, but let's finish with var. There are also various differences in scoping of the var keyword, but you will discuss them once you understand functions at a later time. So let's continue on with let. We just learned it, so let's continue on with it. So let is now the preferred keyword to declaring variables, if I can say it like that. What I mean by that is that variables that are meant to be reassigned to another value. So just like var, a variable can be declared with let and updated within its scope. So let's say my name string, and we can just reassign a new value, and this will work just fine. So of course we need to test that first. Other string. So it got reassigned. But if we do this, this will already throw an error. It's already been declared, but let's just run it anyway. So we can see we get an error. With let and const, we really can't redeclare variables as we could with var. And this is one improvement, I would say, because this helps you avoid many bugs. So just do keep that in mind. Now, the hoisting of let, just like var, let declarations are hoisted at the top, but unlike var, which is initialized as undefined, the let keyword is not initialized. So if you try to use let as we did before, let's try to do that actually. Right now, we get another error because cannot access my name before initialization. So yeah, that's basically one difference with hoisting. It does get hoisted, but it doesn't get assigned a value. So that's one more difference. Let is the preferred alternative to var though, because it solves all of the scoping issues that var has, and you are less likely to run into unexpected bugs by using let. The reason I'm telling you about var in the first place is because, again, before ES6, var was the only option to declare variables, and you might get to work with projects that are older and use var. So basically, I'm telling you so that you are aware of it. That's basically it. Don't really use it for production or any day-to-day activities, because you should always prefer the new ES6 variable declarations like let and const. So we're going to discuss const in just a moment. So variables declared with the const maintain constant values. const declarations share some similarities with let declarations. So let's first of all declare a new, again, basically just a simple string. But what limitations const introduces is that we can no longer update the values or redeclare the variables. So if I try to do something like this, oops, sorry, string, it already throws me an error attempting to override my name. Let's just run it. And yeah, we get the same error we just saw, assignment to constant variable. We can't really do that. And of course, we can't redeclare as well, just as we can't with let. So basically, the only difference between let and const is that you cannot change the reference point to the variable when you declare a const variable. So please prefer to use let and const when you can. Again, you should avoid using var, but be aware of it. And one more thing to note here is that JavaScript is a dynamically typed language. This means that you don't have to specify the data type of a variable when you declare it. So it also means that data types are automatically converted as needed during script execution. This might be a weird concept if you're coming from a strictly typed language background like C# or Java, but you will get used to it. So what I mean by that is basically if we have, let's say, a variable answer, which is a number type, right? Because one is a numeric value, right? And if we change answer to be a string variable, JavaScript sees no problem with that. Sees no errors, and let's console log out the answer. And there we go. So basically this happens because, again, JavaScript is a dynamically typed language compared to a static type language where you would need to like specify that this is a number, and if you try to assign a string, you throw an error, but yeah, there's nothing like that in JavaScript. So that's one more thing to note. Oh, and by the way, since we have learned variables, I can finally tell you another cool trick with defining strings using the backtick. So you should use backticks when you want to insert a variable into your string. It has a special syntax as well, so let me show you. Let's say we have the same answer variable here, and we want to say so. Okay, so we use the backticks, right? The answer is, and since you don't know backtick notation yet, you would do something like put the string here and do concatenation, space here, and you will get the thing that the answer is 1, right? So, but the easier way to do that is actually use backticks. So basically what backticks does is just defines a simple string as we have discussed before. So the answer is space. And if we want to insert a variable here, we use a special syntax like $sign and curly braces, and we use the variable name here. The answer is 1. And basically anything inside these curly braces can be a JavaScript expression. For example, we can do something like this as well, and it will still work. The answer is 4. Or we can of course use variables and basically anything here. So yeah, that's one more thing to know. And lastly, let's finish off with the last two of the main primitives, null and undefined. So basically, they are both pretty similar in the case that they represent no value. And that sounds pretty weird, but let's try to understand this concept. Now, I don't know if you noticed it, but you have already encountered undefined when we were testing out strings. If you try to access a string index that is out of range, you will get undefined. So what I mean by that is, let's say we define one string, again, name. So basically this has a length of 6, right? So if we access the last letter, of course, so log, basically this is the last letter, it should print out G, see G. If we go out of bounds, by the way, the 6th index is not defined in the variable name, so let's see what happens. It says undefined, as it should, because it basically has no value at this index. It's not defined there. So yeah, that's pretty much what undefined is. Or we can actually create a variable and not assign anything to it. Let's do let, just to avoid this error. All right. And we get again undefined. which is also correct. I think it's pretty self-explanatory. If we don't define a value, we get undefined. But null, on the other hand, also declares that something has no value, but it was specifically assigned a null value. So it is defined, but it has no value. So we can use both null and undefined as we did other primitives. They're like a reserved keyword, and we can use them directly. Let's actually try it out and assign null to this variable here. So that is basically it. So we have to specifically assign null for this variable to be null, and here we go, the answer is null. Of course, we can also do undefined here, but that's really rarely used. And if you actually want to specifically tell that a variable has no value, you should always go to null. That's basically it. So we can move on to comparisons now. We know many comparison operators from maths. In JavaScript, they're written like this. So greater or less than. It also has greater, less than, or equals with the equal sign. Then the equality, and here's a note that please note that the double equality sign means the equality test, while a single one means an assignment, as we have did previously with variables. So this is different. A single equal sign is assignment, double equal sign is an equality test. Not equals as well is written with the exclamation point and an equal. And one more thing to note here, that all comparison operators return a Boolean value. I think it has no exceptions, so yeah, basically every comparison returns true or false. And of course, a comparison result can also be assigned to a variable, just like any other value. So do keep that in mind as well. Okay, so up next is string comparison. We have covered numbers, so now let's move on to strings. To see whether a string is greater than another, JavaScript uses the so-called dictionary or lexicographical order. So in other words, strings are compared letter by letter, as you can see some examples here. So I'll try to explain the algorithm to compare two strings. So basically, we compare the first character of both strings. Then if the first character from the first string is greater or less than the other strings, then the first string is greater than the second, and we're actually done. But otherwise, if both strings' first character are the same, compare the second character the same way, and repeat this until the end of the string. If both strings at the end are the same length, they are equal. Otherwise, the longer string is greater. So in the first example above, the comparison z is more than a gets to a result at the first step. So basically just one character. The second comparison, glow and glee, needs more steps as strings are compared character by character, as I mentioned before. So let's try to do that. So G is the same as G, right? So the next letter L is the same as L. And lastly, we come to O, which is greater than E, and we are stopping there. The first string is greater. So one thing to note here, that do be aware when comparing string numbers, as most of the times you might get unexpected results. For example, 11 as a string is lower than 2 as a string, which when we would compare it as numbers, it would be false, but when comparing strings, it is true. So alphabetically, this is correct, but most of the times we want to compare numbers by their values, so it's important to check out the data type. When comparing values of different types, JavaScript converts the values to numbers. So for example, 2 as a string greater than 1 is true because the string 2 becomes a number 2. And for example, 0, 1 as a string equals 1 is also true because 0, 1 is converted to 1. So basically for Boolean values, true becomes 1 and false becomes 0. And that is pretty much there is to it. Okay, so next up is the strict equality operator. So we have used the regular equality for our examples now, but this is very important because a regular equality check, which is double equality sign, has a problem. For example, it cannot differentiate 0 from false, as we can see in the first example here, because it thinks 0 equals false is true. And for example, an empty string equals false is also true. So this happens because operands of different types are converted to numbers by the equality operator, and an empty string, just like false, becomes 0. But what to do if we'd like to differentiate 0 from false? Well, a strict equality operator, which is written by free equal signs, checks the equality without type conversion. So in other words, if A and B are of different types, then strict equality A and B immediately returns false without an attempt to convert them. So basically, there's also strict non-equality operator, which is basically the exclamation point and two equality signs, which is analogous to the non-strict non-equality operator. The strict equality operator is a bit longer to write, but makes it obvious what's going on and leaves less room for errors, and you should always use it. Actually, there are very rare cases when you should rather use the regular equality operator, so just stick to strict. So our next topic is logic and conditionals, and really quickly, I'd like to take a moment to explain why you should put extra effort about this section. So in this section, we're going to talk about decision making in JavaScript. But these principles will apply to pretty much any programming language. The concepts here are pretty universal, and that's why they are important to understand. Okay, so when I say conditionals, I'm referring to having different outcomes based off of certain conditions. Take Facebook, for example. You come to Facebook and you don't see my profile or wall since you're currently not logged in with my account. All you see is the login screen. Without conditionals, which help determine whether you're logged in, we wouldn't have this fundamental functionality. Once you do click login, you begin to see your wall, profile, messages, and everything else. That is what conditionals are on a high level, but we will dive in a little bit deeper. But before we do, I'd like to introduce a few small expressions or function calls, which you will learn about later in more detail, but for now, don't try to understand how they work. Their syntax is pretty simple. So the prompt, alert, and confirm functions. So we'll start off with alert. So basically it shows us a message and waits for the user to press OK. For example, alert, and we run it, and we see this small box up here which says hello there, which we specified inside the parentheses. Okay, so next up is the prompt function. So basically what it does, it shows a modal window with a text message and an input field for the user and the buttons OK and cancel. The usage is pretty simple. We only need to specify a variable, which we will store the answer in, call prompt with the message. What's your name? Oh, we need to escape that. Start running it. What's your name? So I input it, and there we go. Now, basically this doesn't really give us anything good, so let's see if it worked again. And we can see it got the answer. Basically, it stored my answer in this answer variable, and that is basically what prompt does. It also accepts a second optional parameter, which you can set the default name to. Let's say anonymous. So right now we already have a predefined value here, but we can delete it and still do the same thing, right? So that's prompt. Oh, and if you click cancel on prompt, it returns null. And lastly, a pretty similar function in terms of functionality is that confirm function. So what it does is basically it shows, again, the prompt with the options yes or no, or is it okay or cancel, I'm not sure. It really depends on the browser. So basically, are you enjoying this? Let's see what happens. Are you enjoying this? Okay or cancel? Okay, so yeah, two options. If we click OK, the returning value is true. And if we click cancel, the returning value is false. And that's basically like prompt, only this is a true or false situation. Alright, so with that out of the way, we can now interact with the user and use the power of conditionals to make decisions based on their input. So we'll start off with the if statement. The if statement evaluates a condition in parentheses, and if the result is true, as a Boolean, executes a block of code. Let's try it out. Alright, so let's first of all define a variable for us to store the answer to. Let's say I'm going to call it year. I'm going to prompt the user on, I guess, which year was ECMAScript 2015, specification published, something like that. ECMAScript is the same as ES6, it just has different like counting, I guess. Okay, so we have this here, so let's run it and see if it works. Okay, so no errors now. So I will create an if statement now. If the year is 2015, and I'm actually not sure what I think it's a string, to be honest. So, yeah. Let's alert that you are correct and see if it works. Let's say I run something else, nothing happens. What if I input the correct answer? You are correct. Because the condition, what happens is basically is a simple equality check for the year, the variable year, to be equal to 2015. But it can be much more complex than that. I guess we can not only like write a simple alert, but we can write, for example, 2 alerts. Great job. Let's try and run it. You are correct. That's the first line. Great job. That's the second line. So we can basically execute as much code as we want inside these curly braces. This is what's called a block. Like anything inside these curly braces is a block. Another important thing to mention is that the if statement evaluates the expression in its parentheses and converts the result to a Boolean. So let's quickly recall the conversion rules to Booleans. It's basically a number 0, an empty string, null, undefined, and not a number all become false when converted to Booleans. Because they are also called falsy values for this reason. And basically anything else besides these values that I mentioned are going to be converted to true, which is also called truthy values. And what I mean by that is that code like this would never execute because 0 is evaluated as false. And on the other hand, code like this would execute because 1 is a truthy value. It is converted to true. And for example, these if condition statements don't really need to be statements. They can also be actual variables. Let's say if we store this condition into a variable, all of these equality operations always produce a Boolean, by the way. So we can just store it here and see if that works. Yep, still works. Now, continuing with this example, the if statement may contain an optional else block. It executes when the condition is falsy. For example, we have this condition here. So if the condition right here is false, we will execute this block. Let's say that so basically this will execute any time when year is not 215, right? So let's test it out. Let's see if it still works. You are correct. Great job. And if I input something wrong. Yep, there we go. I get the else block, which says that you are wrong. And there it is. Sometimes we'd like to test several variants of a condition. So that's where the else if clause helps us out. So for example, let's actually remove everything here. And yeah, let's remove this as well for the sake of clarity. So first of all, if the year is below 215, right? So we will alert that too early. Now the else if the year is not lower than 215, we will execute the else if, which will say that if the year is above 215, we will of course alert that it's too late. And now if both of these are wrong, that means that the year is equal to 215, and that's what we want. So we bring in the else here, alert, you are right. Okay, let's test it out. Too early. What about if I input 216? Too late. And what about the answer? 2015. You're right. So in the code above, basically, JavaScript first checks if the year is below 215, right here. If that is false, he goes to the next condition, which is the year greater than 215? And if that is false, he just goes to the else, because there's nothing else to do. By the way, the else statement is optional. You don't need to specify it. Like, if both of these are falsy, nothing will happen. But if we specify this else statement, it will execute every time each of these conditions don't satisfy the constraints. And by the way, there can also be more else if blocks. Just be sure to actually specify the else at the bottom, or else it will be executed even before these get a chance to be evaluated. So if the year is, for example, 218, let's say we have this secret. Oh, and that won't work because this condition got fired off first, so let's just move it above. It's a good example. Secret. Because this got executed and nothing else really matters here. You can also use a sequence of question mark operators to return a value that depends on more than one condition, although this is not really encouraged, but I will show you anyway. Let's change it up a bit. Prompt, age, yeah, so this will be good enough. And now we won't use access allow, but a message to the user, right? So let's begin. First of all, let's change it to message. Okay, so first of all, the condition, let's say, is age is less than 3, right? So we assign the value hello little baby, right? And if it's false, we put an enter there for better readability, although this is not really readable. But let's say if age is not less than 3, let's evaluate a new condition. If age is less than 18. All right, so if it is true, then say hello. If it's not, if it's more than 18, let's add another condition. If the age is below 100. Hello adult, I guess. It's pretty hard to think of these situations, but basically I think that's enough for the conditions, but we still need to specify if the age is above 100, because right here we put in a semicolon, so right now we still need to specify basically a value to return if the age is above 100. So let's say, wow, that's a lot, I guess. That works. You need to skip that as well. Okay, so let's try it out. Let's first of all try the first condition. Hello, little baby. Okay, that works. What about 3? Hello. So this is the second condition, right? As we can see here. Okay, so anything above 18, 19. Hello, adult. Okay, so that works as well. And the last condition, 101, I guess. Wow, that's a lot. Okay, so that was the last condition. So it might be difficult to grasp what's going on, but taking a closer look, we can just see that it's an ordinary sequence of tests. Basically, it's not one, but just instead of returning a value, we return another test. So we can actually try to rewrite this using if-else statements, because personally, if there is like more than one condition, I would avoid using this ternary operator. It's more of a true-false situation, but let's do it anyway. So, okay, so first of all, the age is 3, so we just do this. So the else if return this. All right, forget these. There's another condition here, which is age less than 100. Hello adult. And if everything else fails, we just return, wow, that's a lot. And of course, we will test it out. So 2, oh, something didn't work. Oh, sorry, I re-declared my variables. Hello little baby, 18, hello adult, there's also 17, hello, and anything above 100 is, wow, that's a lot. So that's basically all there is to it, the ternary operator. Alright, so next up is the switch statement. A switch statement can replace multiple if checks. It gives a more descriptive way to compare a value with multiple variants. So the syntax is as follows. The switch has one or more case blocks with an optional default. So it looks like this, as you can see. The value of x is checked for strict equality to the value from the first case, that is value 1, then to the second, value 2, and so on. If the equality is found, switch starts to execute the code starting from the corresponding case until the nearest break, or until the end of switch. If no case is matched, then the default code is executed, if it exists, of course. A small note here, but pretty important, is that don't forget to use the break statement in each case, or the switch statement will just not stop until the end. So yeah, let's go on to a live example. Alright, so we have a pretty simple variable here, it's 2 plus 2, so basically we can just leave it as 4, but for interesting reasons, let's just keep it as an expression. So what happens here is that the switch starts to compare this variable a, this one, from the first case, that is 3, right here. So this match fails. Then it starts comparing with 4, and that's a match. So the execution starts from case 4 until the nearest break. So what that means is that this switch statement should only alert one time. So let's try it out. Exactly. So yeah, it did. And if there is no break, then the execution continues with the next case without any checks. So let's actually delete these break cases right here and see what happens. So basically nothing else changed, only that I deleted the breaks. So let's see. Okay, so we have exactly as we expect, but we also have the case 5 because it doesn't even care anymore. If it finds a matching case, it's just going to continue on. So it also matches case 5, which is not exactly what we want, so it says too big. And even the default statement, I don't know such values. So what's important here is that always remember to break, unless you want this unexpected functionality, of course. Now, also keep in mind that any expression can be a switch or a case argument. So both switch and case allow arbitrary expressions. In this example, here a plus gives 1 because it converts. That's basically, by the way, another way to convert a string to a number. So this gives out 1. And that's compared with b plus 1 in case. So while b is being 0 plus 1, it's now equal 1. And then this case matches. And this does not, because this has been matched and we have a break statement here, so let's run it. And we see exactly that. Alright, so another example for switches is the grouping of case. So several variants of case which share the same code can be grouped. In this case, we have grouped case 3 and case 5 because case 3 has no break statement, right? So if case 3 matches, it's just going to execute until it finds a break. So that means it's going to execute case 5 as well. It doesn't even care if the a is equal to 5. So this ability to group cases is actually a side effect of how switch works without break. So basically, we avoid the default statement because case 5 does have a break, and once case 3 executes without the break statement, it's still gonna find this break statement here. So that's the difference between our example without any breaks at all. So that's pretty much what grouping is. Alright, so next up are the logical operators. There are 4 logical operators in JavaScript: or, and, not, and nullish coalescing. The most important operators are the first 3, but I will also cover the new ES 2020 nullish coalescing operator. Although they are called logical, they can be applied to values of any type, not only Boolean. Their results can also be of any type. Let's continue on into code editor. We'll start with the OR operator. The OR operator is represented with 2 vertical line symbols. In classical programming, the logical OR is meant to manipulate Boolean values only. If any of its arguments are true, it returns true. Otherwise, it returns false. In JavaScript, the operator is a little bit trickier and more powerful. But first, let's see what happens with Boolean values. So, as you can see in the example here, there are 4 possible logical combinations. The result is always true, except for the case when both of the operands are false. If an operand is not a Boolean, it's converted to a Boolean for the evaluation. What I mean by that is, for instance, the number 1 is treated as true and the number 0 as false, as we have talked about earlier. So if I would write something like this, this would be treated as same as true or false, which is basically true, as we can see here. So most of the time, an OR operator is used in an if statement to test if any of the given conditions are true. A more lifelike example, actually, let's just delete those as well. Let's say current hour is 9, and if the hour is less than 10 or the hour is greater than 18, then we will alert that the office is closed, right? Because it's not working hours. Let's try it out. The office is closed, and if it's, let's say, middle of the day, oh, it doesn't do anything yet because there we go. We can also pass in even more conditionals. Let's say a Boolean is weekend false, and if is weekend is true, then the office is automatically closed, right? It's pretty logical. So, oops, I'll say false. So currently it should still work. The office is open, but if we change this to true, then it's automatically closed. And that's pretty much it. So what we did here is pretty classical behavior, right? So let's bring in the extra features of JavaScript. I'm going to delete that. So the extended algorithm works as follows. Let's say we have a variable here. We have value 1, oops, value 1, or value 2, or value 3. So given multiple OR values, the operator does the following. Evaluates operands from left to right, so basically from left to right, value 1, value 2, value 3, and for each operand converts it to Boolean. We already covered that. If the result is true, it stops and returns the original value of the operand. And if all operands have been evaluated, what that means is that basically everything here is false, then returns the last operand. So a value is returned in its original form without the conversion, and in other words, a chain of OR returns the first truthy value or the last one if no truthy value is found. For instance, let's try that. Alert 1 or 0. What do you think is going to happen? it's going to output 1, because 1 is truthy. It was the first value. It never even evaluated the 0. What about if we pass in a falsy value like null and give it a truthy value at the end? What do you think is going to happen? It still outputs 1, because null is a falsy value. It then tries to evaluate the other operand, and it sees that this is a truthy value. It just returns it. So we can also do this with another falsy value, so that it evaluates that as well. And it still returns 1, because null is falsy, 0 is falsy, and 1 is truthy, right? And what happens if all of them are falsy? Let's say an empty string. We get the empty string because this is falsy, and this is falsy. But if everything is falsy in the OR chain, we get the last value. And by the way, we get the original value as well. It's not converted to a false, but we get the original empty string. To be clear, I'll just change this to be an empty string and this to a 0, and we get the 0. So what does this mean for you? So I'm going to show you a quick example of, for example, getting the first truthy value from a list of variables or expressions, as we discussed again, but this is going to be a live example. So for instance, we have, let's say, first name. Actually, we don't really need to define them. Or actually, we do. That first name is a falsy value. It's an empty string. Last name is also empty. And also nickname, I guess, let's leave it empty as well. And let's do a check. So an alert. If all of these fail, we just default back to anonymous, right? Let's see if this works for now. Oh, we get anonymous. All right, so basically what this function does is finds out, basically tries to console log out any variable that is truthy in this order. So if we would define, let's say, a nickname for now, instead of anonymous, we get nickname. If we were to define first name, since it's the first in the chain, we're going to get first name. No longer the nickname, but the first name, because we find the first truthy value, we don't even evaluate the rest. And that is one use case. And another feature of the OR operator is the so-called short circuit evaluation. It means that the OR processes its arguments until the first truthy value is reached, and then the value is returned immediately without even touching the other argument. The importance of this feature becomes obvious if an operand isn't just a value, but an expression with a side effect, such as a variable assignment or a function call. Let's say we have this example of like alert, run, and false. All right. Oops, sorry, that was the other way around. Run. It's basically in the first line, the OR operator stops the evaluation immediately upon seeing the true, so the alert isn't run. And on the other one, it sees false and tries to evaluate the second one. So sometimes people use this feature to execute commands only if the condition on the left part is falsy. For example, setting the default value or anything similar. All right, that is pretty much it for the OR operator. Let's move on to the AND operator. The AND operator is represented with two ampersands. In classical programming, AND returns true if both operands are truthy and false otherwise, as you can see in the example above. An example with if, let's say we have minutes and hours. So we want to check if hours equal 12 and minutes equal 30. We will alert it is 12:30. So basically, if hours and minutes. Basically, it's the other way around compared with and. So, and of course, just as with or, any value is allowed as an operand of and. What I mean by that is you can basically have something like this. It's not going to run because this is converted to true. This gets converted to false. If this happens, then it will run. Just like we did with or, we can also do extra stuff with and. For example, if we had this results variable, value 1 and value 2 and value 3, the AND operator does the following. It basically evaluates operands from left to right, as we did with OR. For each operand, converts it to a Boolean, same as OR, and if the result is false, stops and returns the original value of that operand. And if all operands have been evaluated, what that means as well is that all of the values were truthy, it just returns the last operand. In other words, AND returns the first falsy value or the last value if none were found. The rules above are similar to OR. The difference is that AND returns the first falsy value, while OR returns the first truthy value. So, some examples. Say we have this. What do you think this is going to return? Oops, it's not defined. Let's just delete that. Return 0 because 1 is truthy and 0 is falsy. In either case, we just return the last value here. But what about if they're both truthy? It still returns the last value. But what happens if the first operand is falsy? It returns the first falsy value, which is 0. And that is correct. We can also pass several values in a row. For example, 1, 2, and let's say 3. Turns null, since it's the first falsy value here. You can also just delete that, and still gonna return null. Also, as I mentioned before, when all values are truthy, it just returns the last value. One thing to note here is that the precedence of AND is higher than OR. So the code, for example, in B or C and D is essentially the same as we would wrap them in parentheses, so you don't really need to worry about that. So yeah, basically the same. With parentheses or not, it will take higher precedence than the OR operator, always. So next up is the Boolean not operator. It's represented by an exclamation point, so the syntax is pretty simple. Let's say here. So this is the not value. The operator accepts a single argument and does the following. So basically converts the operand to Boolean type first, and then returns the inverse value. For instance, let's say we have this, Boolean true. It returns false. Because basically it just converted it to Boolean, which is already a Boolean, and it reversed it. So reversing means true becomes false and false becomes true. A double not is sometimes used for converting a value to Boolean type. For example, some string, whatever. And we get true, because a string is truthy. And what it does is basically it converts it to false first. This first exclamation point converts this to false. It's right now. And then the other exclamation mark converts it to true again. And that is pretty much it. The only thing I want to note again is that the precedence of not is the highest of all logical operators, so it always executes first before the ands or the ors. And lastly, the nullish coalescing operator. It's written as two question marks, like this. As it treats null and undefined similarly, we'll use a special term here. We'll say that an expression is defined when it's neither null nor undefined. So for example, the result of A, knowledge coalesced B, is that if A is defined, then the answer is A. Then return A. But if A isn't defined, then return B. In other words, the knowledge coalescent operator returns the first argument if it's not null or undefined. Otherwise, the second one. The knowledge coalescing operator isn't anything completely new. It's just a nice syntax to get the first defined value of the two. We can actually rewrite this right here using, let's say, if A doesn't equal undefined and A doesn't equal null, then we use the ternary operator, return A in this case, or B. That is pretty much it. So this is what happens under the hood of A knowledge coalesce B. So let's see where it helps. I had to move to Replit for this example because apparently JS Fiddle doesn't support ES 2020 yet. So yeah, the common use case for the knowledge coalescing operator is to provide the default value for a potentially undefined variable. So for example, let's define a user, alert, user. If the user is not defined, show anonymous. Let's run it. Here we see anonymous. It's not going to run alerts here because this is like a different environment, but you get the idea. Let's define user now. Say give him John. It returns John as expected. We can also use a sequence of these knowledge coalescing operators to select the first value from a list that isn't null undefined, which I already mentioned. So for example, we have a similar example as we did with the OR. See what happens. We get cool def as expected because this is in this sequence, this is the first one that is actually defined. So you've seen a pretty similar example with the OR operator, as I mentioned before. For example, the code above could be replaced with OR operators and it would work the same way. And historically, the OR operator was there first, actually. As I mentioned before, it exists since the beginning of JavaScript, so developers were using it for such purposes for a long time. But on the other hand, the nullish coalescing operator was added to JavaScript only recently, and the reason for that was that people weren't quite happy with the OR operator. The important difference between them is that the OR operator returns the first truthy value, and the nullish coalescing operator returns the first defined value. So in other words, OR doesn't distinguish between false, zero, empty string, null undefined. They're all the same, falsy values. If any of these is the first argument of OR, then we'll get the second argument as the result. In practice though, we may want to use default value only when the variable is null or undefined. That is, when the value is really unknown or not set. For example, let's consider this. Let's say we have height is set to 0 and alert height or 100. Do the same with the nullish coalescing operator, right? Let's run it. 100 and 0, that's basically the difference here. So this returned 100 and this 0. So the first example here checks height for being a falsy value, and it's 0. Well, 0 is falsy. So the result of OR is the second argument, 100. And on the second example, it checks if the height is being null or undefined, and it's not. So the result of height is as is, which is 0. In practice, the 0 height is often a valid value, so that shouldn't be replaced with the default. So nullish coalescer operator does just the right thing in our case. And that's basically the use case for it. Okay, so basically we covered everything there is to know about logical operators in JavaScript, and let's continue on with loops. We often need to repeat actions in our code. For example, outputting goods from a list one after another, or just running the same code for each number from 1 to 10. Loops are a way to repeat the same code multiple times. And here you can see the different loops that JavaScript gives us. So we will cover each of them with examples, but this is just an overview of their syntax and their required parameters. So basically, first of all is the while loop. So the while loop runs while the condition is truthy, and the code from the loop body is executed. So basically, while condition is truthy, we just run the comment, like anything that is inside the block, the while block. I think a live example would be easier to understand. Okay, so this is a pretty simple example of a while loop. Let's first of all run it and see what it does. Okay, it says 0, 1, and 2. So basically what it does is while I is less than 3, run this code. So alert, I is pretty self-explanatory, but this, we didn't cover this incrementing operator. What this does is basically just adds 1 to I. So it's the same as writing, I plus 1. Or, and also a pretty cool syntax is this. These three are all the same. So a single of execution of the loop body is called an iteration. The loop in the example above makes 3 iterations, right? And if this incrementation of I was missing from the example above, the loop would repeat forever. In practice, the browser provides ways to stop such loops, and in server-side JavaScript we can actually kill the process altogether. Actually, we can try it. Let's just set it to console log, just not to spam too much. Let's see what happens. It's not. It appears it's not even running. So I think it handled these loops. Yeah, because basically this would be running forever. Because I is always 0 and each. Oh yeah, there we go. Page unresponsive. Whatever. Any expression or variable can be a loop condition, not just comparisons. So the condition is evaluated and converted to a Boolean. Like anything here is converted to a Boolean. Right? So for instance, a shorter way to write, for example, I 0 would just be to write like this. Because while I is truthy, while I is not 0, it's just going to be truthy. So it's basically the same thing as writing it like this. The use case for it is doing it the other way around. Oh my god, this is not going to stop, is it? We just need to decrement it. Maybe if I run it again. No, it crashed forever. Okay, I'll just restart later. But that's pretty much what the while loop is. There's nothing more to it, so let's just move on to other kinds of loops. So the other type of loop you might encounter is the do-while loop. So the condition check can be moved below the loop body using the do-while syntax. The loop will first execute the body, then check the condition, and while it's truthy, execute it again and again. So we have an example here. Let's run it. Okay, so 0, 1, 2, oops, and okay, we're done. So this form of syntax should only be used when you want the body of the loop to execute at least once, and that is the main difference between while, regardless of the condition being truthy. So usually the other form is preferred, and I mean the while loop. And I think that I have personally never used do while in a real world situation, so if you have a very specific use case, you should know about do while, but basically you should just stick to while because it's a bit safer and less prone to bugs. All right, so There's not much more there to it. It's almost similar as well, so we're just gonna move on. Okay, and finally the for loop. The for loop is more complex, but it's also the most commonly used loop. It looks exactly like this, and we can first run it to see if it works. So 0, 1, 2. All right, so now let's break it down. Basically, there's 4 parts here. This is the beginning, right? So executes once upon entering the loop. So once we define the loop, this is where we define all of the variables that will be used inside this loop. Then we have a condition here, so checked before every loop iteration. If this is false, then the loop stops. Then we have the loop body, which gets executed every iteration. And lastly, we have the step. So basically it executes after the body of each iteration. So basically what happens is that we define a variable I, we give it a value of 0, then our loop starts, it checks the condition. If I is less than 3, then execute this loop, it does that, and then it just goes back. It skips this part since it's already done. But before actually restarting the loop, it does the step part, which increments I variable by 1. So right now it's 1. The condition is still true, so we execute the function again. And lastly, this is 2. It's still the condition is still true, so we run it again. Iteration step, it's now 3. This condition is false, and this body is never executed. So let's review that again if I'm correct. So okay, 0, 1, 2, and 3 never gets executed. There's also inline variable declaration. So here the counter variable I is declared right in the loop, and this is called inline variable declaration. So such variables are visible only inside the loop. I have mentioned during our variables section that let, const, and var have different scoping behaviors, but I did not elaborate on that part just yet. So let and const are block scoped, which means that they are accessible inside a block, or in simple terms, I've already mentioned, anywhere between parentheses, so basically inside here. And vars are global or function scoped, which means that they are either accessible from anywhere globally or from inside a function body that declared them. We didn't really cover functions just yet, but just keep that in mind when you do. So basically, if we were try to access I after the loop, let's just delete this for now so it doesn't see what happens. Oh, I is not defined because this I was only defined on this block. If we were to change it into being var, then this gets accessed. It's now free. Because in this case, var only has function scope or global scope. And since this is not a function, var gets global scoped, and it is accessible from anywhere. A way to fix this is actually declare the variable, let's say outside the function, and just use it there. And now it should work again. So normally a loop exits when its condition becomes falsy, but we can force the exit at any time using the special break directive. For example, the loop you see here asks the user for a series of numbers, breaking when no number is entered. So the break directive is activated when value is null. Well, basically when the user either inputs nothing or clicks cancel. So actually let's try it out. So let's input 1, 2, 3, and nothing. And we get 6 because our break got activated, and basically what break does is just basically passes the control to the first line after the loop. So in our case, it's this alert here. And why is this useful? Well, basically the combination of, let's say, an infinite loop, which you see here, while true, it's infinite, it's never going to end, except if we break, is great for situations when a loop's condition must be checked not in the beginning or end of the loop, but in the middle or even in several places of its body. And this is just one example, but we can have like plenty more if statements here. If values, for example, like 55, we don't want that, so we just break the loop as well. And it won't get summed. And that's just one simple example. And now the continue directive. Well, the continue directive is a lighter version of break. It does not stop the whole loop, but instead it stops the current iteration and forces the loop to start a new one, if the conditions allow. We can use it if we're done with the current iteration and would like to move on to the next one. So the loop you see here uses continue to output only odd values. So for even values of I, the continue directive stops executing the body and passes control to the next iteration of 4 with the next number, Well, basically the step, and then we just continue on again, as I mentioned before. So the alert is only called for odd values, or if this condition is not true. So let's run it. 1, 3, 5, 7. So basically only odd values. And since it stops at 10, it just broke the loop. And that's pretty much it. That's basically everything you need to know about JavaScript loops. And this was part 1 of the JavaScript course, and I hope you found this useful and informative. I hope you learned something new. We will continue on in part 2, where we talk more about the non-primitive types of objects, methods, and maybe some functions. But yeah, this would be a bit too long for one part, so meet you there.